Hello and welcome to your first video of the year. Today we're going to talk about symmetry. Anytime we've got a video, your job is to write down everything you see on the screen and anything important that I say or that I write. As I give you practice problems to try, I want you to pause the video, go ahead and try them, and then I'll reveal how it's supposed to go. Today we're talking about symmetry. I'll let you see the screen for a moment. Every shape, there's two possible kinds of symmetry that a shape could have. It could have reflection symmetry, it could have rotation symmetry. It might have one, or it might have neither of them, or it might have both. And often we're going to try to determine what kind of symmetry this shape has. Reflection symmetry is just the ability to draw a reflection line that flips it back onto itself. Meaning, if we have something like this, okay, I drew a reflection line here because we can see, you can visualize that we could flip this shape and it would look the same after it's flipped than it did before it's flipped. So this does have reflection symmetry because here is a line that will work. This triangle may or may not have reflection symmetry. The important clue, if I told you that this was 90 degrees, then that would be really helpful for us. It would not work to flip it like this, up and down. That wouldn't work. It also would not work to flip it side to side. Those ways to reflect would not work. Some people give up and say, well, then it does not have any reflection symmetry. But the reality is, you could flip it this way. If it's 90 degrees, then that means if I split it here, it's 45 and 45 on each side. And so I could reflect it over that line if I were to draw it straight. And it would make a reflection symmetry. Okay, rotation symmetry. That's when it's possible to turn the figure so that it maps onto itself. You can pause the video to write this down if you need. So what we're looking to do is to see, can we turn it and have it be the same as what we started with? Something like this. It kind of looks like a Pac-Man eating to the right. If I turn this shape, will it ever look the same? The same, the same, the same, the same, the same, the same? No. It's different all the way around, so this does not have reflection symmetry. Or does not have rotation symmetry, sorry. It actually doesn't have reflection symmetry either. We can't draw a reflection line on this guy either. Now the pentagon, what about that? Well, we could see if we turn it, will it ever look the same? Ah, right there it looks the same as what we started. There it looks the same. There it looks the same. And there it looks the same. 4 times, and actually the 5th one will get us all the way around. So we would say this has rotation symmetry. Now, we want to be able to give the angle number, the degree number for that rotation symmetry. Everything in the universe has 360 degrees. I could turn this pen all the way upside down and back to where it started, and that's 360 degrees. So we don't really count that because everything has it. But something like this, we would say, okay, how many turns, or what percentage of the way around until it's the same? So since we knew we had to go 5 points that would turn it, right, 1/5 of the way around would give us reflection, or would give us rotation symmetry. So, since it's 1/5 of the way, we take the 360, which would be the turn all the way around, and we just divide that by 5. And we would say this has 72 degree rotation symmetry. Because every 72 degrees, it looks the same as what we started with. Okay? Now, go ahead and pause the video and try, we don't count 360, go ahead and try the 4 that you see right here. A, B, C, and D. Pause. Unpause. All right, this one has reflection symmetry. We could draw a line here. We could also draw a line here. That would work. It also has rotation symmetry. We can grab it, we can turn it, and look, it's the same, like right there, it's the same. So we would say, yes, it has reflection symmetry. Yes, it has rotation symmetry. So reflection, and it has rotation. Rotation looks like it would be 2 turns, right? So 360 divided by 2, that's 180 degrees. Okay, this quadrilateral here looks like it's a parallelogram. There is no reflection line here. It's close there, but not quite, because if you flipped it, this would go up a little higher, and this would come down lower. It wouldn't be the exact same. This does not have reflection symmetry. but I believe it does have rotation. If you were to turn this halfway around, it's the same, right? So halfway around and back again to the top. So that is 360 divided by 2. That is 180-degree rotation symmetry. This star, we could get a line here, we could get a line here, we could get a line here, we could get a line here. So actually 4 different lines of reflection. And then we could also have some rotation on this as well, right? I think a quarter of a turn gets us back to be the same thing we started with. So 1, 2, 3, 4, it's going to be 4 turns here. A quarter of a turn gives us rotation symmetry. So we would say 360 divided by 4, we would say this has 90-degree rotation symmetry. The letter H, well, we got a line here, we got a line here, so, oops, down the middle. So it does have reflection symmetry, and I'll bet if we turned it upside down, it doesn't have to be in the same position, it just has to be the mirror image. It's the same image. So we would say, yes, this has rotation symmetry, and we have reflection symmetry. That's what you need to be able to do about symmetry.